Bootes Void, the Great Nothing. Imagine setting off in a spacecraft, expecting to see stars, galaxies, and cosmic light shows, and instead, you find nothing. That's the Bootes Void. First identified in 1981 by Robert Kirshner and his colleagues during the CFA Redshift survey, a comprehensive attempt to map galaxy distributions in the northern sky, it stood out as a massive spherical region, curiously devoid of galaxies. Using the Multiple Mirror Telescope and 1.5-meter instrument at the Fred Lawrence Whipple Observatory, the team noticed a gap in the data that simply couldn't be explained away by observational error. Spanning an estimated 330 million light-years in diameter, the Bootes Void is one of the largest known voids in the observable universe. That scale is hard to fathom. If the Milky Way were the size of a grain of rice, the void would be the size of Mount Everest towering over the Earth. Or better yet, an entire continent stretching across the planet. While most regions of the universe are teeming with galaxies, hundreds per cubic megaparsec, this cosmic desert contains only a few dozen known galaxies across an unimaginably vast area. In terms of size and sparsity, this void dwarfs most other voids. Even massive voids like the KBC void or the local void are modest in comparison. Its extreme underdensity, less than 1/10 the average cosmic galaxy density, defies the expectations of large-scale structure formation models. It's not just empty, it's anomalously, disturbingly empty. Some cosmologists propose that the void was formed from overlapping smaller voids merging over billions of years, a cosmic version of bubbles popping together. Others hypothesize that early quantum fluctuations, or dark energy irregularities, could be at play. There are even fringe theories speculating whether such a void could be evidence of interaction with another universe or an imprint left from cosmic inflation. Regardless of the cause, the psychological weight of the void is what sticks with most people. It's not simply the absence of matter, it's the silence. A hole in the map of the cosmos so large and so empty that it feels unnatural. It's the kind of place where, if you found yourself inside, you might start to wonder if the universe had simply forgotten you existed. Gamma ray bursts, the universe's ultimate explosions. Now imagine this. You're casually observing a distant galaxy when, suddenly, an intense flash of high-energy radiation erupts and outshines everything in the sky, just for a few seconds. That's a gamma ray burst, or GRB, and it's one of the most violent and energetic phenomena in the known universe. First detected in the late 1960s by US military satellites, known as the Vela spacecraft, these bursts were initially suspected to be secret Soviet nuclear tests. It wasn't until scientists realized they came from deep space that GRBs became one of the greatest astrophysical mysteries. Over time, observations from instruments like NASA's Swift and Fermi gamma-ray space telescopes have shed more light on them. GRBs are now classified into two types based on duration and cause. Long-duration bursts last more than 2 seconds and are typically linked to the death of massive stars collapsing into black holes. Short-duration bursts, lasting less than 2 seconds, are thought to result from the collision of neutron stars. Both can trigger supernovae or colonovae, leading to the dispersal of heavy elements like gold and platinum across the cosmos. What makes them terrifying is their sheer power. A single gamma-ray burst can release more energy in a few seconds than our sun will emit in its entire 10 billion-year lifespan. These blasts are so bright that they can be detected across billions of light years. If a GRB were to occur within a few thousand light years of Earth and be oriented toward us, the consequences would be catastrophic. It could strip away the ozone layer, bathe the surface in lethal radiation, and potentially trigger a mass extinction event. Some scientists even propose that a GRB may have contributed to an extinction event 450 million years ago, which wiped out nearly 85% of marine species. Despite their rarity, GRBs are unpredictable and virtually unstoppable, making them one of the universe's most haunting threats. They serve as both a reminder of the violent processes shaping the cosmos and a warning of the dangers lurking in the deep dark. TON 618, the monster black hole. If there's one celestial object that embodies the extremes of scale, it's TON 618, the largest known black hole ever recorded. Located over 10.4 billion light-years away in the constellation Canes Venatici, TON 618 isn't just massive, it's incomprehensibly massive. With an estimated mass of 66 billion times that of our Sun, it dwarfs every other black hole humanity has confirmed to date. TON 618 was first cataloged in the 1950s as a faint blue object, and it wasn't until the 1970s that astronomers realized it was a quasar, a supermassive black hole surrounded by an actively feeding accretion disk, emitting immense radiation. To get a sense of its size, the event horizon, or the boundary beyond which not even light can escape, would stretch over 1,300 astronomical units in diameter. That's more than 30 times the distance from the Sun to Pluto. If you replaced our Sun with TON 618, its gravitational pull would envelop the entire solar system and beyond. The sheer brightness of TON 618's quasar means it's still visible from across the cosmos, even though the light we see left it over 10 billion years ago. It's a snapshot from an era when the universe was only about 3 billion years old, and already capable of producing such monsters. How something so enormous came to be is still a matter of intense scientific debate. Some researchers believe it formed from the merger of many smaller black holes in dense galactic environments. Others suspect it grew from massive Z black holes born shortly after the Big Bang, fed by an abundant supply of gas in the early universe. Perhaps the most unsettling thing about TON 618 is that it exists at all. Its presence challenges our understanding of black hole growth rates and cosmic evolution. How did something that big form so quickly? And if TON 618 exists, how many more behemoths are lurking out there just beyond our reach? The silence of the cosmos is one thing, but knowing there are invisible giants like TON 618, ancient, colossal, and unstoppable, adds a new kind of dread to the equation. The dark flow, a one-way ticket. In 2008, scientists analyzing data from a NASA probe discovered something they didn't expect: a mysterious, large-scale motion of galaxy clusters moving in the same direction at unusually high speeds, up to 1,000 kilometers per second. This flow wasn't accounted for by the expansion of the universe or known gravitational structures. They called it the dark flow. To visualize it, imagine standing in a field of tall grass and noticing all the blades leaning in the same direction, even though there's no wind you can feel. Something unseen is pulling at the fabric of the cosmos, and we don't know what. What's most unnerving is where it seems to lead, toward a region of space beyond the observable universe. That's right, it's not just unexplained, it's possibly unexplainable. If the dark flow is real, it might be a sign that our universe is being influenced by massive structures outside our cosmic horizon, structures we'll never be able to observe directly. Some theorists suggest these movements could be caused by the gravitational pull of a neighboring universe. Others propose that this is just an artifact of data misinterpretation. Yet the signal persisted in multiple independent analyses, using different methods. Even though newer observations from the Planck satellite haven't confirmed the dark flow with high confidence, the debate continues. If it turns out to be true, it would mean that our understanding of the cosmos, its shape, size, and boundaries, is incomplete. And few things are more unsettling than being pulled towards something you can't see, can't study, and can't escape. Neutron stars, cosmic pressure cookers. Imagine something so dense that a single teaspoon of its material would weigh 1 billion tons. That's a neutron star. These are the ultra-dense remnants left behind when massive stars go supernova. They're small, typically only about 12 miles across, but their mass can be up to twice that of our Sun. The concept of neutron stars was first proposed in 1934 by Walter Baade and Fritz Zwicky, just 2 years after James Chadwick discovered the neutron. But it wasn't until 1967 that the first real candidate, a pulsar named CP1919, was detected by Jocelyn Bell Burnell and Anthony Hewish. The regular radio pulses it emitted were so strange that for a moment, the discovery was jokingly dubbed the work of little green men. What makes neutron stars terrifying isn't just their density, it's their extreme nature. Their gravity is intense enough to bend light around them. Their magnetic fields are trillions of times stronger than Earth's. Some rotate hundreds of times per second, creating beams of radiation that sweep across space like cosmic lighthouses. And then there are magnetars, a rare type of neutron star with magnetic fields so powerful that they can distort atomic structures. A nearby magnetar flare could fry Earth's satellites and cause widespread electromagnetic disruption. One particularly famous magnetar, SGR 1806-20, released a flare in 2004 that briefly altered Earth's upper atmosphere despite being 50,000 light-years away. These stellar corpses push the limits of physics. We still don't fully understand what happens in their cores. Matter is compressed so tightly that atoms themselves are crushed. They exist right on the edge of our understanding of the laws of nature. And in that unknown lies a uniquely unsettling type of fear, the kind that doesn't come from monsters or voids, but from the universe itself breaking its own rules. Rogue planets, wanderers in the void. Picture a planet like Jupiter, except it doesn't orbit a star. It floats freely through the galaxy, untethered and alone. These are rogue planets, worlds that have either been ejected from their star systems due to gravitational interactions or formed in isolation, never bound to a parent star. The existence of rogue planets was once purely theoretical, but that changed in the early 2000s. One of the most notable discoveries came in 2013 with PSOJ 318.5-22, a massive, free-floating planet about 80 light-years away. This world, roughly 6 times the mass of Jupiter, was detected through direct imaging by the Pan-STARRS One Wide Field Survey telescope. It remains one of the best-studied rogue planets to date, providing evidence that such bodies are not only real, but perhaps common. Scientists believe that for every star in the Milky Way, there may be as many as 2 rogue planets. That could mean hundreds of billions of these dark, nomadic worlds drifting silently through space. They are typically detected through gravitational microlensing events, when a rogue planet passes in front of a distant star, briefly magnifying its light due to the planet's gravitational field. Unlike planets that orbit stars and reflect starlight, rogue planets emit no visible light, making them incredibly difficult to spot. Some may still retain internal heat, possibly warming subsurface oceans or atmospheres with geothermal energy. It's even hypothesized that a few might be able to support life under thick ice layers or within deep pressurized environments. What makes them especially eerie is their stealth. If one were on a collision course with our solar system, we might not detect it until it was dangerously close. These are worlds without homes, cold, quiet, and unreachable. As next-generation telescopes like the James Webb Space Telescope and ESA's upcoming Euclid mission begin their surveys, we expect to uncover many more of these planetary phantoms. Until then, they remain as cosmic ghosts, out there, somewhere, drifting silently across the night. Space is full of secrets that defy logic, and if any of these gave you chills, drop a comment and let us know which one stuck with you.